Hello students, today we're going to be talking about the application of inequalities, which is just a fancy way of saying how we see inequalities in real world situations. So the notes page that you picked up when you walked in is going to be page 118 in your math binder. We are still in Unit 7. Make sure that you fill out your table of contents so that you know where you can reference this page whenever we have an open note quiz. Next, when looking at your notes page at the very top, again, it says application of inequalities. And when solving these types of problems, really, these are the kind of problems you're going to see on your district assessment. They're all word problems and they give you scenarios. So we have to remember the following questions to ask yourself as you solve real world problems. Number one, in this first box here, what information are you given? So maybe underline or box in whatever information you're given. Then you're going to determine what you're supposed to solve for, what you're supposed to look for. And then after that, does your solution make sense? Is it reasonable in the context of your problem? So let's look at the first one together. We're just going to practice setting up an inequality for each of the situations below, but we're not actually going to solve them. So for number one, it says that the school football team is selling raffle tickets for a fundraiser. Okay, I'm given that information, but there's also no numbers for me to pay attention to yet. So that's the scenario. They're selling raffle tickets. It costs $155 to print the tickets. That's important, so I'm going to go ahead and underline that. Now I know my cost of the tickets, and they would like to make at least $2,500 in profit. And they said the word at least. They want to make at least. That's important, so I'm going to circle that as well. It's not a definite $2,500. It's at least that much. Now it says how much money do they need to raise to cover the printing costs and to meet their goal. So when looking for my variable, the variable is essentially the question that you're answering. So it says how much money do they need to raise to cover the printing costs and to meet their goal? So that means we're looking for how much money they have to raise, okay? Now it says, what does the variable represent? I'm going to go ahead and put M for money because that's what we're searching for. How much money do you need to raise? And then I'm going to write an inequality to represent this situation. I know that it costs $155 to print the tickets. I also know that they want to make at least $2,500 in profit. So I'm going to put that over here, $2,500. And if they're trying to make at least, that means that they could make $2,500 in profit, but they also would like to make more than that because $2,500 is the very least that they want to make. So now I need to really go back and read this question. It's saying how much money do they need to raise to cover the printing cost? That's important. It must cover the printing cost and meet their goal. So no matter what, they have to cover the printing cost plus meet their goal, okay? So what I'm going to do for now is I'm actually going to go back and I'm going to erase my 155 and I'm actually going to move it over because my money, my variable, has to be enough to cover that cost plus how much they want to make. So I'm actually going to subtract here. My inequality is going to be a subtraction because that money has to be greater than the cost of the profit or the cost of the printing plus the profit. So I know I'm going to want to add in order to solve this, which means that this needs to be a subtraction problem. The money minus the cost of the printing has to be greater than or equal to how much money they want to raise. So that would be my inequality. Moving on to question number 2. Westfield Junior High is attending a field trip to the planetarium. Students must be placed into groups of 15, and the planetarium can only accept up to 18 groups per day. Okay, so this is important. Students must be placed into groups of 15, and the planetarium can only accept up to 18 groups per day. So no more than 18 groups per day. How many students can attend the planetarium field trip each day? Okay, so let's break this down. What they're searching for is how many students can attend the planetarium. Okay, so my variable is going to be students. What's the total number of students that can attend the planetarium each day? Well, we said they can only accept up to 18 groups per day. So that means that no matter what, my number of students cannot exceed 18 groups per day. So therefore, I'm going to go ahead and do a less than or equal to 18 groups. Okay, the number of kids can't be any bigger than 18. So my value for my students is going to be X. I know that. And they're split into groups of 15. So they're divided into groups of 15. X divided by 15, my total number of kids, divided into 15 groups, cannot be any bigger or can be exactly equal to my 18 groups per day. So that's what my inequality would look like. All right, now we're going to set up an equation and solve using a real world scenario. So here we go. For number 3, Frances is saving money for a new tablet. She needs to save at least is important, that tells us our sign for inequality symbol, $200, and has decided to save $10 per week. So every single week, she's saving $10. How many weeks is what we're looking for? Will it be before she can purchase the new tablet? So, what do I know? I know she needs to save at least $200. Okay, and I also know she's going to save $10 every week. $10 per week. Okay, what I need to know is how many weeks she's going to save for. So now I'm going to plan my work. Here we go. I'm going to start off with my inequality symbol. It says she needs to save at least $200. So I'm going to put 200 over here. Now, her money that she saves can be more than $200 because at least is her bare minimum, or it can be equal to $200. At least or equal to $200. And I also know that she's saving $10 every single week. So what I'm going to do is I'm going to assign that week a variable of W, and she's going to be saving $10 every week. So that's going to be a multiplication problem. $10 every week times her number of weeks will get her at least or equal to $200. Now I'm going to solve. I solve by getting my variable all by itself. So right now 10 is being multiplied with W. I'm going to divide by 10 on both sides. Now 10 is canceled out, making W by itself. I divided by a positive number, so I do not need to flip my sign. And now I have 200 divided by 10, which I know is 20. Okay, because my zeros cancel out, making that 20 over 1, which is 20. So my solution is her weeks need to be greater than or equal to 20, in order for her to save up enough money for her new tablet. Now, if I want to go ahead and put this on a number line, I've got 18, 19, 20, 21, 22. I'm going to go ahead and put a closed dot on 20 because I know that she needs to save for 20 weeks or more, because this is a greater than sign. Weeks need to be greater than or equal to 20. So that means my arrow is going to go this direction. Okay? And that would be the solution to this real world problem. Go ahead and make sure this notes page makes it into your math binder. Please do not turn it into the basket. And go ahead and either work on homework or Education Galaxy until it is time for your next rotation. All the best.